So to start this out, I'm going to tell you a story. This is a story about a jury. Our class has been selected to serve on a jury in a criminal trial. As jury members, we must start with the assumption of innocence, because the defendant is assumed innocent unless proven guilty. Remember that guilt must be proved beyond a reasonable doubt. We can only reject the assumption of innocence if the evidence of guilt is extremely strong. Avoid the mistake of convicting an innocent person. In our justice system, this mistake is considered much more serious than the mistake of acquitting someone who is guilty. If we think about that last statement, convicting an innocent person is the same as rejecting the assumption of innocence when the defendant actually is innocent. We want the probability of making this mistake to be very small. So here's our class, listening to all the evidence, all the testimony. How are we going to determine what verdict to give? If we could find some way of coming up with a numerical measure of the evidence, that would really help. From what we know of statistics, we could take that numerical measure of the evidence and find the relative position for that in some probability distribution. So we could find a percentile or a z-score or something that would tell us the relative position of that measure of our evidence. Once we knew that relative position, then we could measure the probability that the defendant is actually innocent, given the strength of that evidence. So here's our evidence that we're starting with. If our evidence is not very strong, that means the probability of innocence is not small. It might not be large, but on the other hand, it's not small. That would lead us to a verdict of not guilty. Another way of thinking of a verdict of not guilty is that we do not reject the assumption of innocence. On the other hand, if our evidence is very strong, that means the probability of innocence is very small. This would lead us to a verdict of guilty. And another way of thinking of a guilty verdict is that we're rejecting the assumption of innocence. On this side of the decision-making tree, if our evidence is extremely strong, then the probability that the defendant is actually innocent is very small. And this is the one that we want to be very small, because we don't want to be convicting an innocent person. Let's leave our story for a little bit and talk about the elements of a hypothesis test. So this is terminology and notation translated into plain English as much as possible. So when we're doing a hypothesis test, we have something that was our original claim. The goal of research or study is to determine whether this claim is likely to be true. Now, our alternative, or what we sometimes call our research hypothesis, the notation for this is H with a subscript 1. This represents the original claim. What we call our null hypothesis is H sub naught. This represents the status quo. Our significance level, which we call alpha, this is the probability of a type 1 error, which would be rejecting the null hypothesis when the null hypothesis is actually the true one. A test statistic is a measure of the relative position of the sample statistic. So a sample mean, a sample proportion, something like that, using a probability distribution. A p-value is a value that's based on the test statistic. It's the probability of the test statistic being at least that far out in the tail of the distribution. The initial conclusion is based on a comparison of alpha, the significance level, and the p-value. And our initial conclusion always has to do with the null hypothesis. We either say reject the null hypothesis or do not reject the null hypothesis. Our final conclusion is a statement of the results of the test in terms of the original claim. In other words, this is a statement in English saying that either the evidence is sufficient to support the claim or it's not sufficient. Now, how is hypothesis testing related to our jury story? In hypothesis testing, we have an original claim, which translates into an alternative hypothesis. In our jury story, this would relate to the claim that the defendant committed the crime. In a hypothesis test, we have the null hypothesis, which represents the status quo. In our jury story, this would be the assumption that the defendant is innocent. That's the assumption that we're starting with, and we can't reject that assumption unless we have very strong evidence. Now we have our significance level alpha, which is the probability of rejecting the null hypothesis when the null hypothesis is true. This would be like the probability of convicting an innocent person. So it's the same as the probability of rejecting the assumption of innocence when innocence is actually the true status. Our test statistic in our jury story would be the measure of the strength of the evidence, whatever measure we could come up with. The p-value relates to the probability that the defendant is innocent given the strength of the evidence. The initial conclusion in our jury story would be our decision to reject or not reject the assumption of innocence. And the final conclusion would be related to our actual verdict, guilty or not guilty. In other words, on our jury, we're saying either yes, there's enough evidence for us to conclude that the defendant is guilty, or no, there's not strong enough evidence to conclude that the defendant is guilty.